Astronomers have announced the detection of the long-suspected gravitational wave background, ripples in the fabric of space and time coming from all directions in the sky. It's the result of 15 years of observations by the North American Nanohertz Observatory for Gravitational Waves, or NanoGrav. Previously, gravitational waves had been detected in one-off bursts due to the merger of stellar black holes and neutron stars. But the gravitational wave background comes from all around, and is much more powerful and lower in frequency. A single rise and fall of one of the waves could take years or even decades to pass by. Since gravitational waves travel at the speed of light, a single wave could be tens of light years long. NanoGrav scientists revealed the presence of the waves by observing several dozen pulsars using a collection of radio telescopes across America. Pulsars act like stellar lighthouses, sending out regular radio pulses in our direction as they spin rapidly around. If a gravitational wave passes between us and a pulsar, it throws off the radio wave timing. That's because the wave stretches and compresses space itself, changing how far the radio waves have to travel. Theories had already suggested that collisions between distant supermassive black holes ought to give rise to a gravitational wave background, but the newly detected waves are about twice as loud as predicted. In fact, they're at the upper limit of what would be expected from supermassive black hole collisions. Perhaps there are more such collisions taking place than astronomers had thought, or it could be that part of the gravitational wave background has another source altogether. String theory, for instance, predicts that one-dimensional defects in spacetime known as cosmic strings may have formed in the early universe. These strings could dissipate energy by giving off gravitational waves. Another idea is that the universe didn't start with a big bang, but with a big bounce, as an earlier version of the universe collapsed in on itself before entering a new phase of expansion. In that case, gravitational waves from the rebound would still be rippling out through spacetime. Having made their historic breakthrough, astronomers are now keen to move on to study the gravitational wave background in more detail. Their observations will help to shed new light on the fate of supermassive black hole pairs, and on how often galaxies have collided throughout the history of the universe.